So we talked about normal distribution. Okay, so normal distribution is our bell curves. One of the things that we talk about in this first information talking about it is that the mean, median, and mode are all equal, but everything's centered around the mean. Okay, and then our standard deviation determines how the bell curve spreads out. Okay, so if we look at this first example, the normal curve shown at the right, which normal curve has the greatest mean? So where is it centered at? Okay, so the left one has the greatest, okay, because the center of it is the furthest to the right. And what is that mean? 60. So curve B has the largest mean. What mean of 60? What can you say about the mean of curve A and curve C? They're the same. Okay. And then part B, determine which normal curve is more spread out. So then what can you say about which deviation is the greatest? So which one is the widest curve? C. So we can say curve C has the greatest standard deviation. Okay, because it's simply the widest. So all of these normal curves, we can narrow it down to the standard normal curve or normal distribution. Okay, so this is a normal distribution with a mean of 0 and a standard deviation of 1. Once we've transformed from our x value into our z-scores, then we can use that to find the area under the curve or the percent of data that lies within a range. Okay, so that's where we're going to be looking at. Remember, we're going to round to the nearest hundredth. There are 2 decimal places. So we're going to use the standard normal table to find these areas. So to find the cumulative area that corresponds to a z-score of 1.15. So go over to your tables. And you're going to want to go to, I think it's table 5. Or maybe it's table 4. It says standard normal distribution at the top, page A16. So page A16 has all of your negative z-scores. And then the next page has all of your positive. So we were looking at the z-score of 1.15. So looking down the left column, we're going to go to 1.1. And then across the top, we're going to look for the 0.05. Line those up. So that area is 0.8749. And that's your answer for part A. Okay. So the next one, find the cumulative area that corresponds to a z-score of negative 0.24. Looking at your tables, we're going to go to negative 0.2. And then the thing you have to be careful about on the negative one, it goes backwards. Okay. So if you look at the top, 0.04 is further to the right. And what would that area be? 0.4052. Okay, what about for a z-score of negative 2.19? So you're staying on that same page. Go to negative 2.1. And then you're looking at 0.09. And what is that z-score going to be? 0.0143. And last one, z-score of 2.17. Okay, so you're gonna have to look at the positive one. So the next page. So go to 2.1 and then 0.07. So what would that z-score be? 0.9850. Okay. Questions with finding z-scores in the table? Any questions at all? Okay. So when the z-score is not in the table, you're going to use the entry closest to it. So this is why we always round z-scores to 2 decimal places, is because 2 decimal places on the table. The only time we're not going to round to 2 decimal places is if you get like 1.645, because then you can look in between 1.64 and 1.65 and find the average of those 2 areas. Okay, and we'll look at an example of that later. All right, so now we can apply that to a more general application of it. Okay, so finding areas under the standard normal curve, you're going to always start off with sketching the graph. And then we have 3 different scenarios. So we're finding the area to the left of some z-score or data value. Okay, you sketch your curve. And then 0 is always in the center. And just put some z-score somewhere. Okay. And then to sketch that, you're going to draw a vertical line up and just shade everything to the left. Okay, so that's what your sketches are going to look like. If you look at your tables, and I'm going to switch back over real quick. At the top of it, it gives you that picture of the normal curve. Okay, all of the areas we just found were all areas to the left. Okay, this picture shows you that it will always be the area to the left. So for that first situation, we're just going to look at the table. So look at table 4 or 5. You don't have to do any extra work when you're looking for the area to the left. If you're looking for the area to the right of a z-score, well, we know anything we get from the table shows us to the left, but we also know the area under the curve is what? 1. So you're going to do 1 minus the area to the left. Okay. And that's what you're getting from the table. Okay. And then if you're finding the area between 2 z-scores, if you can't tell, I'm very bad at sketching these. I'm going to say z1 and z2. Okay, so if you want to find in between 2 of them, you're going to find the area of z2 minus the area of z1. Okay. Here's the key. You're always going to do big minus small. We're never going to have negative areas. They're always going to be positive. So if you don't know which one to subtract, find both areas, big minus small. Okay. Questions with that? All right. All right, so we're going to do 3 examples. So find the area under the standard normal curve to the left of z equals negative 0.99. So sketch your curve. Okay, so negative 0.99, that falls to the left of 0. Draw your vertical line and then sketch it to the left. Okay. Then go over to your table. Go to your negative side. And look for negative 0.99. I'm going to erase all these others. Okay, so we're looking at negative 0.99, which gives us 0.1611. And that is your answer. Okay. So second one, find the area to the right of z equals 1.06. Sketch your curve. And since it's to the right, we have to do 1 minus. So look at your table. Oops, wrong button. Go to your positive side. And then look at 1.0 and then 6 from the top. And what do you get?
1 minus 0.8554.
Correct. 0.8554. Okay. And something I'm going to add in here in this little sketch, the area in this white spot is that 0.8554. Okay. So then go ahead and subtract, and we get 0.1446. Okay. And then the last one, find the area under the standard normal curve between z equals negative 1.5 and z equals 1.25. So sketch your curve. Shade in between them to show where that area is coming from. And then you're going to find the area for both z-scores. Okay, which one's going to give you the largest area? Just the larger number. The positive one. So we're going to do the area of z equals 1.25 minus the area of z equals negative 1.5. Okay. So looking at your tables, what do you get for the area of z equals positive 1.25? 0.8944 minus, what's the area for negative 1.5?
0.0668.
Okay, 0.0668. And then subtract those. If I can type it in correctly, it's helpful. And you get 0.8276. Okay. Okay, so what we're going to be looking at in the next few days is in changing our data entries. So taking our X values, changing them into Z-scores to then determine the probability of something happening. Okay. So the only thing you're looking at today is finding those Z-scores and changing them into area. Okay.